Welcome to RC Filters Review. All right, this question, you may not remember it, but in second semester, you should have gone over a couple of formulas. They were in the math, the electronics and computer math 8th edition by Deem. And it's in chapter 23, and there's a couple of formulas here that you kind of just need to know, or at least know where to go look them up when these types of questions show up. And so the first formula is AV is equal to, and that's AV in dBs, gain in dBs, 20 log of 1 over the square root of 1 plus F1 over F, that quantity squared, and the other formula that you need to know, change colors, is AV equals 20 log 1 over the square root 1 plus F over F2. Squared. Okay, so let me explain these formulas a little bit. So we've got a Bode plot. Something like that. And right here, we have our F1. And right here, we have F2. Or our frequency critical low, or our frequency critical high, or cutoff frequency low, cutoff frequency high, however you want to say it. But that is your F1 and F2. Now, using these two formulas, we can find the dBs down on basically on this line right here. Any of these frequencies, we can find the dBs. We know that the critical frequency were minus 3 dB. But this question is kind of asking, what's the gain at frequencies beyond the cutoff? And so for the red formula, the first F1, in this question, you're looking at a FC1 of 50 hertz. So 50 hertz divided by, you're interested in finding the dBs at 40 hertz. So 50 divided by 40, square that, add it to 1, take the square root of that, invert it, take the log of that, and multiply that by 20. Now that's going to give you the dBs down from the critical. So notice though in this question it's giving us in terms of 20 dB. So we're 20 dB right here. Let me change that color. So there's our 20 dB. So our 20 dB mark is right here across the top, right in our mid band. So if we're 20 dB right here, whatever this answer is going to be out of the formula here, you're going to need to subtract that from 20 dB. So you're going to be down below 3 dB, which would be the critical, for example, at 40 hertz right here. At 40 hertz, you're going to be below 3 dB. You know that. But in order to find the actual dB down, use the formula and then subtract that number from 20, and that will give us the dB down from 20, or the actual dB that we're at. Now the same thing with the other side. Now you're interested in 25K. So you're going to take 25K divided by F2, which is your 18K. And I'll do all the math there. And then this gain is going to be down from 0. So you're going to shift it to 20. 20 minus that number is going to tell us the dB that we're actually at. Okay. So we've got a high pass filter. Let's draw the response curve. That. There's your high pass. So we know that the cutoff frequency, 90 hertz. And we're interested in the dBs at 70 hertz. Okay, so we know that this is F1. There's F1, or frequency critical one, FC low. So we know our AV. We're going to look at FC1 over F squared. So we want to put in 90 hertz over 70 hertz, square that, add it to 1, take the square root, invert that, take the log of that, multiply by that by 20. And because they didn't give us an initial dB gain at the midband, we're assuming that that is at 0. That's our 0 dB mark. So we know that at 90 hertz, we should be minus 3 dB. And at 70K, we're going to be something less than that. And that should be this number right here. Right, so the first thing we want to do is establish the Bode plot. So we're looking for F1 and F2 so that we can then use those formulas to figure out, where are we going to be at dB wise at 30 hertz and 50K hertz. So we know that at the cutoff frequencies, X of C's are going to be equal to the R Thevenins. And we know that this coupling, this guy right here, it's going to affect our FC1, and this guy right here is going to affect our FC2. And we know that at FC2, X sub C1 is going to be acting like a short. So let's do R Thevenin for C1. So good. Now at this point in the Bode plot, X sub C2 is acting like an open. So we can see that R Thevenin C1 is equal to R1 plus R2. We know that X of C is equal to 1 divided by 2 pi FC, and at frequency critical, X of C and R equal. So we can manipulate this formula, 2 pi R Thevenin C. Okay. Now, let's do the formula for R Thevenin C2. So R Thevenin C2, C1 is now acting like a short. So we can see that R Thevenin is equal to R1 in parallel with R2. Now we can find F2. Okay, let's do this, make this guy red. So now we've got F1 and F2. And once you've got F1 and F2, now you can use the two formulas that I referenced earlier in the video, and you can find where we're at dB wise on the 30 hertz and the 50 kHz.